This is how to manage releases using Git Tags Semantic Versioning. I'm your presenter, Mike Miles. My pronouns are he, him, and I'm excited to be part of GitKon 2021. So again, my name is Mike Miles. I've been working professionally as a web developer since 2006. Majority of that time has been storing my code in Git repositories. And currently I am the director of web development at MIT Sloan, where it's the responsibility of my team and I to make sure that among other things, the school's website is up and running at mitsloan.mit.edu. And we do use Git for managing our code base there. I'm also the host of Developing Up, which is a podcast focused on the non-technical side of being a developer. So anything that has to do with having a career in development, but not about writing code, is what we cover in those episodes. You can find me all over the internet with the handle MikeMiles86 on Twitter, on LinkedIn, on GitHub, etc. So if you want to find any more about me, do a search for that handle, I guess. Okay, so let's start off by stating, what is a release? When I talk about managing releases, what am I talking about? In the context of this talk, a release is anytime you're packaging code up to go to production, whatever your production environment is from your Git repository. That could be that you're deploying code to your website server, your production server, that you are generating an artifact to release a new version of your mobile app or your program or what have you. A release is packaging up code, a set standard version of your code, and pushing it to whatever your version of production is. That's what we're talking about today. The thing about releases is that the longer you maintain a project, potentially the release management of that project can get messier and messier. It can be messy, especially if you don't have a standard in place, a concrete way or concise way that you are following with you and your team to determine what a release means in terms of what's changed in your code base since the previous version. If you don't have a reliable way to do this, then down the line, 6 months from now, when you're looking to what a release was 6 months ago, you may not understand what you actually pushed out with whatever your named release was. That's why in this talk, what we're going to talk about is how you can use semantic versioning along with Git tags in your Git repository to create and easily manage releases and indicate the degree of changes in your production code. So what we're going to talk about today, first is just the basics of semantic versioning and what it is. Then we're going to talk about the basics of Git tagging and what Git tags are and how to use them. Then we're going to talk about how you combine the two together to create semantic Git releases. And then from there, we're going to go over some tips for generating helpful release notes for anyone who may be viewing your releases and hopefully provide them with some helpful information to know if they can get the latest version of your production code. Let's dive into it. Semantic versioning, what is it? Semantic versioning is just a number schema. That's all it is. It's a pretty industry standard practice for software development to indicate the degree of changes that have gone out since the previous production release of a piece of code. Semantic versioning is used by everybody. When I mean everybody, I mean pretty much everybody. If you look at any piece of software you use today, most likely they're tracking their changes using semantic versioning. So if you look at your OS, like I'm on a Mac right now, that version release for your OS is probably going to be a semantic version number. If you look at any of the browsers you're using to view the web, they're tracking their changes using a semantic version number. If you're tracking the programs you use to do whatever on your phone or on your computer, what have you, they're probably tracking their changes using semantic versioning. All the way down to the tools you use, like Git. Git tracks its changes using semantic versioning. So everybody uses it, and you can use it too to track your changes. The structure of semantic versioning is pretty straightforward, and I think this is why a lot of people have adopted it, because it's a clear, concise way to indicate a level of changes. And there's 3 parts to a semantic version number. There's the major, then .minor, then .patch. And each one of these, when you increment them, means something different. It means a different degree of changes have gone into your code base. Let's start with patch. When you have a patch release, when you go from version 1.0.1 to version 1.0.2, this indicates that there have been bug fixes or trivial updates. Anything that isn't a major alteration to your functionality, that's what a patch release indicates. A minor release, so going from version 1.0.2 to 1.1.0, this indicates that there's been change to functionality, but in a way that is backwards compatible. So it could be a functionality change, a functionality update, adding new functionality, potentially removing functionality depending on the degree of it, but in a way that if someone were upgraded to that new minor release, they don't have to worry that it's going to break however they were using the application or the product previously. A major release, so going from version 1.1.0 to say version 2.0.0, this indicates a potentially non-backwards compatible breaking functionality changes. This could be everything from removing deprecated code to introducing a complete re-architecture of your application. It's something that tells people that, hey, this is a major change. If you are on the previous version, it may not, that previous version and the data related to it may not work anymore unless you follow some specific steps. So a different degree of changes are indicated if you're updating major, minor, or patch. Now, versions, when you create a semantic version, they're set in stone. And what this means is that once it's released, that version cannot be changed. And what that really means is once you've marked a version of your code base with a semantic version, you are not supposed to change what state of your code that version points to. So if you've released version 1.3.0, so a minor release, and you realize you missed something, well, you can't add it to your Git repo and then re-tag that commit if you've released it to your production environment. What you have to do is any additional changes need to be a new release. And the worst case scenario for this, we'll say in the world of Git, is if you say you release version 2.0.0 of your application, and then you realize you forgot to add a bunch of files to your repo, they're just sitting there on your local machine. Well, you would have to create a new major release. You'd have to go immediately from version 2.0.0 to 3.0.0, and it's not fun for anybody. So using semantic versioning in your project, you do need to be responsible for double checking your version number before you release it, because as soon as it goes out into your production environment, you have to assume that somebody's using it. Again, this depends on what sort of application you're building or code base you're maintaining. But if you build something that goes out to the public, like even like an NPM package or something, as soon as you push out the release to your production environment, you're responsible for making sure that you've correctly identified what changes have been made and the degree of changes that have been made. But because versions are set in stone, this makes them perfect for combining with Git tags. So what's a tag? A Git tag is just a way to add a marker to a commit to signify that it's significant in some way in your code repository. And there's two different types of Git tags. First is just a lightweight tag. Lightweight tags are basically just name pointers to a commit. Literally, it's like a human readable name that you can assign to a commit hash. To generate a lightweight tag in command line, you use the git tag command followed by the tag name and then potentially the hash of the commit you want that tag applied to. But if you omit the tag name, it'll apply it to whatever current commit you are on in your local environment. An example of this is if you use the git show command to view information about a tag. For example, in this screenshot, I have git show tag123. It's going to show me the commit hash that the tag's associated to, and it's just going to show me the commit information for that specific commit. In this case, it's tied to a merge commit. The other types of tags are known as annotated tags, and these are the recommended types of tags to use in your project. These are not just human readable names associated to a commit hash, but they become full objects in the Git database. And I don't have time today to talk about the structure of Git databases, but what that means is that they can be checksummed, that they contain additional information about like who created the tag and when they created it. They have separate messages than just what is part of the commit. And for any public projects, they can be signed and verified using GNU Privacy Guard, PGP, and that allows people to verify that that tag is associated to the state of the code base as it's supposed to be. So example, using the command line git tag command, it's pretty much the same thing, but you just do -a option and then the tag name to stand for it's an annotated tag. And then you provide -m to provide some sort of annotation message. And then optionally, you can provide which commit to apply it to. Example of this, if I were to show a screenshot here of git show for a tag titled version 2.7.46, this shows me the tag name. It shows me the tagger information, which is omitted for privacy purposes here. The day it was created, a specific message, an annotation for this tag, and then the commit information like you would see in a lightweight tag. So the value here is if you take annotated tags and you combine them with semantic versioning. So if you name your annotated tags using semantic versioning, that's where you get semantic releases. That allows you to have mark commits in your Git repository with a specific version. And because you're using semantic versioning, if you change the major or the minor or the patch version number, you're indicating the level of changes since your last Git tag. And it's a very helpful way to demonstrate the level of changes in your code base. The benefits of using semantic releases in a Git repository, like I just said, is it signifies the important changes in your repository. So if you have a tag and you tag it as 1.2.3, you're saying, oh, this is a patch release from the previous one. So that indicates you've just introduced bug fixes, for example. It communicates the degree of changes between tags because you can easily see the previous tag was at version 1.6.7 and the new one is at version 2. There's been a significant amount of changes in your code base between those two tags, between essentially those two commits. So it allows you to review your history and track how your changes were made and when they were made in your code base. It's really helpful to you and your team, and again, potentially to your users if they're viewing your release information. And using semantic versioning for your Git tags is supported by many Git interfaces. Really, a bunch of Git interfaces to support listing tags, but if you use semantic versioning, it'll show them in the correct order. So example here, Git Kraken screenshot, there's a tags panel, which I'll actually show you in Git Kraken in a couple minutes. And it'll list it in numerical order, which is pretty helpful. Or example on GitHub, there's a releases tab that's tied to tags that will also show them, you can easily see. So here it easily indicates to you, like in these screenshots, there's been a bunch of patch updates, right? So just bug fixes have been going on. Nothing major in functionality has changed. Using semantic versioning for naming your automated tags also helps with automating your tools or using your automated tools for your production deployments, whatever you may be using. For example, Circle CI. In your config.yaml for a job, you can indicate that a job should only be executed on certain tags. And if you're using semantic versioning, you can put in a very simple regular expression to track that change and trigger that on only something that matches what would be the structure of a semantic version, a semantic release. You can do the same thing in Bitbucket pipelines with Bitbucket pipelines.yaml file. It's not a regular expression. It uses a glob pattern. It uses a glob pattern. So you can indicate that with just stars and dots. So star, and then execute that pipeline. Or say like if you're using Travis, you could trigger Travis build on a tag, and then you can compare the tag to match the regular expression that it matches a semantic version. So it's really helpful if you want to automate deployments to production and you want to be able to consistently only trigger production builds on certain tags. If you're using semantic versioning, you can easily do that. So creating a semantic Git release using annotated tags and semantic versioning is just a 3-step process. One, you create the annotated tag using the correct semantic version number as the tag name, and then provide some sort of annotation message. You push that tag up to your remote repository, and then insert your deployment steps here for number 3. Whatever your steps for getting your version of your code up to your production environment, however you deploy that, that's your step 3. And I mean, that could be as simple as complex as your project demands. Creating a semantic release tag using command line is pretty straightforward. Again, it's just using that annotated tag command. So git tag -a, and then their semantic version that you're tagging this as, depending on the changes. The pattern that is most usually used for the name is you prefix the semantic version with a V to stand for a version. And then at the very least, for your annotated message, you're doing release and then the semantic version number. So like release 2.7.45. And then you push that up to your remote, whatever your remote is, origin, upstream, what have you. So you push that tag up, and then hopefully your automated tools go from there. Creating a semantic release using tools like Git Kraken is just as easy. I'm going to switch to that now. So here I have my repo that I have here, and you can see over in the left-hand column here in the tags panel, just the release of the tags I have had previously. I'm currently at version 1.0.2 of this repository. So if I want to create an annotated tag, I just find the commit I want to tag. I right-click on it. I go to create annotated tag here. Then I can enter the tag name. So my last one was 1.0.2. So I'll just up it with a patch. I'll do 1.0.3. And then you have to provide an annotation message at the very very least, you do release 1.0.3, submit that, creates that tag. I can see it here, and then I can create the push the push button just to push it up to my remote, or I can right click on the tag and do push to origin in this case, and that's it. That's all you have to do. Pretty straightforward. So now what? Well, release notes. When you create semantic releases, that indicates to everybody who's viewing your releases the degree of changes that were made in your Git repository, right? If you just updated bug fixes, if you've introduced some slight changes to your functionality, or if you made breaking changes. But what it doesn't tell them is what exactly has been changed. So this is where you want to generate release notes, at the very least, to put it as your annotation that are helpful. Because if you just do the bare minimum of saying, which I just showed you, I know in my examples, of release and then the semantic version number, again, this just tells the degree of changes, but it provides no information about what was changed. And while you may be able to get away with this with patch releases, if you're talking about minor or major updates, especially major updates that may require people to do some sort of upgrade process, this provides no information about that. No indication about what functionality you have changed in your minor and your major releases. So the recommended actual minimums for an annotation for a semantic version tag using annotated tags for patch releases, at the very least, just list out your bug fixes. What issue numbers, if you're using an issue queue or a ticket system like Jira, whatever, list out those numbers there with some description about what was fixed. Pull that into, if you're doing a minor release, add to that the list of functionality that you've changed or touched, and then any significant usage details that have changed that your end user should be aware of. And then from there, your major releases, take both what you would do for your patch release and your minor release annotation and add to it a list of what functionality has been removed, a list of what functionality has been added, and then most importantly, if you are introducing breaking changes, what process users have to follow to upgrade from the last release to the next major version. I think that's the most important piece, because that gives people an understanding if they're reviewing, if they want to use the latest version 2 of your project or version 3 of your project, what they would need to do to make sure their system is ready to go to use that next major version. Now, caveat to this for private projects. If your Git repository is private for you and your team, let's say you use it to generate an artifact or build some sort of compiled version of your code to then go to your production environment, you could probably get away with being a little less robust with your annotations in your release notes. What you could have the very least do, I'd recommend for this, is generate a list of the commit messages that have happened between releases, so between your two annotated tags. And this is really helpful if you've put into place a practice with you and your team for providing robust commit messages about what you've changed. That can provide a lot of detail just as is for indicating the level of changes and what has been changed since your last release. You could use Git command line to generate this list of commit messages between tags. So if you use the git log command, if you just say git log, that's going to list out all your commit messages, but you can format that to do -- pretty format : modulus s, which will just list the commit message. And then you can basically what you can do is compare get a list of the commits between two commits. So you can use tags here to do this. So you could say the last release tag name followed by ... and then let's say head. So if you want to compare it to the latest before you generate your next release, or a specific commit if you're going to tie it to a specific later commit. And then I would recommend adding -- no merges flag so that it excludes any merge commit information. You could use this sort of code directly in command line when you're generating your next release for your next annotated tag by popping it into the message flag or the message option in the git tag command. So you could do git tag -a, your next semantic version number, and then for -m for the message. Inside there, you could put a little bash. You write a little bash and you just put this in here to do the git log to generate it from the last release to whatever your current head is or your commit is, what have you. And that will pull in those list of messages for you. And you don't have to do it yourself, compile it yourself. But let's talk about some extra credit. You could go beyond this. You could go beyond just listing out commit messages to really make your release history helpful. What can you do for this? What do I mean by extra credit? Number one, you could add a changelog.txt to your repository and keep a running list of changes in between your releases. When your releases happen, there is a more manual effort here to keep this up to date, but it provides a quick way in your repo for someone just to view, either if they're pulling down your code base or however they're using it, to view what's been changed between releases. It's recommended that you just don't dump your commit logs here. Again, if it's a private repository and that's helpful for your team, you could get away with that, but at least like list the numbers and maybe who made the changes or what it affects and whatnot. You could even get even fancier, and you could publish a page of release notes. Like, for example, Kraken does this, and it looks like they use Markdown, where you could provide some sort of public way to display your notes for your releases and really detailed information about what's been updated, what's improvements been made, what bug fixes there are, any upgrade processes that need to be followed. So this is pretty straightforward. If I go to Git Kraken again, what you can do, and you can't see it because of my screen, but if up in the command bar there is an option to view release notes, and I'll open it up in a tab here. Look, you can view this right here. You can also view it in the browser, but it's very helpful, a very easy way to read about what's been changed. So look at that, they even embed videos about what's new. So it's very cool, very, very user-friendly way to introduce release notes in your project. You could do it too. You could do even more than that, or in addition to that, you could automate your tag generation. Keeping track of what the next semantic release should be for your project. You have to be on top of it, right? And you have to know what changes were made. You have to analyze and compare what was included in between the two tags to know correctly if you're making a patch release, a minor release, or a major release. But if you're hosted your Git repo on, say, GitHub or on GitLab, there are marketplaces for scripts and plugins and actions to help automate generating your semantic releases. I know on GitHub, there's an action that you can get that will, if you follow a certain commit message schema, it'll use that information to automatically determine if it should increment a patch release, a minor release, or a major release for your project, and it'll push it up and generate the tag for you. Very helpful. You could also just try not to repeat yourself and create helpful bash scripts that's specific for your project to help automate repeatable steps. This could be as simple as just taking out the additional commands you have to put in for generating an automated tag with messaging, and maybe you could get extra fancy with how you're combing your commit messages between releases and between tags, and maybe you follow your own format for your project. Like if you prefix it with, say, like a ticket number, and you could get a list of tickets and maybe make API calls. You can get as crazy as you want with it. In fact, you know what? I've already done this for you. I've created a script that does that. Not that this is in any way a presentation to sell anything that I've made, because I've created something that I've added the MIT license to, so you can use it as you want. But I've created a GitHub repo here, which it's a little bash script called tag release that you can pull down and download to your computer. And if you're in your Git repo, all you have to do is just call sh tag release, and if you call it as is, it will try to get your last Git tag, annotated Git tag, and generate the next patch release for it. Or you can define like the version number and say, I want to do, let's see if I scroll down here, the version type, and you can define major, minor, or patch. So if you say it's a major release, it'll bump it up to the next major release, minor to the minor release, or patch to the patch release. And you can get crazy. You can say, what commit you want to compare it to. You can provide your own commit message annotation. If you don't, it'll try to do that get log pretty format to get a list of the commits in between the previous release and the one you're creating currently. You can say what branch it should be on, when this commit should be created. If you want to like generate in the past and retrofit your repository, this will help you do this. So if you want to try this out, you can. And I recommend taking a look at it at the very least to give yourself an idea of what to do. And hopefully that's helpful. So that's it. That's all this talk is covering. And maybe it doesn't seem like a lot, but hopefully it opens your eyes to what you can do for your own Git repositories for generating your own and managing your own releases in a straightforward and repeatable way. And actually, if I go back to that script I just showed you, I was using that for this script. If I go to my tags tab here in GitHub, you'll see I've been keeping track of my changes in here using semantic versioning. You see I had some patch updates here, and then I had a major release, version 1.0, to say this is the first production release, and then some patch updates for fixing some of my markdown, because I'm not the most markdown suave person on my own. But so takeaways from this presentation. Semantic versioning is an industry standard for tracking releases in code. It's something that you can use in your Git repository to track your own changes, to ease the experience and quickly identify the degree of changes made in your code base. Again, patch releases are just for indicating bug changes or bug fixes. So from version 1.0.0 to 1.0.1. Minor releases indicate backwards compatible changes to your features or functionality. So from version 1.0.1 to 1.1.0. And major releases indicate potentially non-backwards compatible breaking functionality changes. So going from version 1.1.0 to version 2.0.0. So a significant amount of changes have been made to your code base between those two tags. Git tags allow you to mark a commit as significant. Lightweight tags just add basically a human readable name to a commit to target it. And annotated tags generate full objects in your Git database and track a whole lot more information about that tag and the commits it was applied to. Naming your annotated tags with semantic version numbers is the simplest way to generate semantic releases. Just anytime you're going to create an annotated tag, look through what change has been made since your last tag and determine, is it a patch release, is it a minor release, is it a major release, and then update the number as needed. And then finally, just as the tags in semantic version number indicates the degree of changes, you want to make sure you provide some sort of usable information to your users, to your team, what have you, about what has actually been changed. So create release notes. At the very least, compile the commit messages and include those in your annotation, generate a change log and keep track of that in your project, create a nice fancy looking release notes, depending if who's going to look at them, just to help you and help track the history in a helpful way, especially if you're making major releases, to indicate what needs to be changed, the process that needs to be followed to update from the previous release. And that's hopefully going to give you a lot of benefits to your project and maintaining it, and get rid of a lot of the mess that you may incur if you don't follow any sort of standards. So I have a couple of resources here that I want to share with everybody that you can take away and use in the future. So I have an annotated version of this presentation available. I have a bit.ly link here. It's bit.ly/GitKon21 semtag. Stands for semantic tagging. So that's an annotated version of this presentation that you can review. It has a lot more text written in it and step-by-step things on how to generate tags. I have a link here to the actual semantic versioning website, semver.org. Semantic versioning itself is currently at version 2.0.0, so that's helpful information. A link here to Git tagging basics from the Git documentation. A helpful guide at changelog.md, which gives you guidelines to follow for writing useful changelog messages that you may want to review. And then a link to that GitHub repo I showed for my tag script that I've only tested on Mac on a GitHub hosted repo. So use as you want. MIT open source license, go for it. That's it. I want to thank you for sticking around and listening to this talk. Hopefully it's helpful information to you. If you want to talk about Git and tagging and semantic versioning, again, I'm on the internet all over the place with Mike Miles 86. Reach out on GitHub, reach out on LinkedIn, reach out on Twitter, though I'm mostly a lurker there. But I look forward to hearing from you, and thanks for listening to this talk.
Mike, thanks so much for being part of GitKon. That was an amazing talk. I think it fits really well into the whole schedule today, following Adam's talk on getting IAC working with AWS and like how do you manage all of that. Well, there's your answer right there.
I was really nervous following that talk, but yeah, I agree. I think it flows very nicely. So
Well, thanks again for coming on here. We're gonna try to get through as many questions as possible in the 15 minutes we have. The first one is not exactly a question, but I'm curious to hear your thoughts on this out loud. Don't have enough room on the caption to put the person's name who put this in there, but it's the Kraken out there. A company tried to implement the semantic versioning. That's when they asked that in the talk. But have 4 numbers. Ran into the product owner saying, no, we can't just pull the release and redo it real fast because people might have the wrong version of the same version. Wrong version of the same version is one of those interesting worlds you can live in conceptually in Git and not many other places. So I would just love to hear a little bit, your initial take on that, like how you would answer that if you heard a product manager tell you that.
Yeah. I mean, especially dealing with 4 numbers, that's your own special little flavor there of semantic versioning. I would say, I mean, you could probably keep that. You can add after the semantic tag like dash, and then people usually do it for like beta and alpha releases. So I don't see why you couldn't do that with some other number and still not technically break the format. Or go up to 4-digit numbers maybe for your patch releases instead of just the 2-digit ones. I mean, you can go up to whatever numbers you want. So it's a comment on, no, we can't just pull the release and redo it real fast because people might have the wrong version of the same version. I don't know how to answer that one. That's a tricky problem. I mean, I agree that you can't just re-tag something with the same version. Every time you do a release, you need to update the version number. So I don't think they're wrong with that if I'm reading that correctly.
Yeah, that does sound like kind of the point of this versioning is that you roll up every
increment. I mean, I've been guilty myself of if I just release something and then like I forgot to add like commit one file, like you can alter a Git tag, but you don't want to make that a habit for sure.
Oh yeah, that would get confusing really fast. All right, moving on. Does it make sense to add generated tags as special comments in source code? Example, add documentation, special comments, then scrape tags and doc notes into logs and doc-wiki docs?
Yeah, I think that does. If you're dealing with a lot of changes, if you have a very active, big project, mono repo, probably pulling in all that documentation into like a changelog file or some other file. And you could definitely write some scripts that if you want to trigger to generate a new release, that it does that, like it compiles all that, adds a file, does the commit for you, and then push it, just adds the version number as the commit number and the release number. So I think it's up to you and your team to gauge what you want to put in as the comments. You may not want to write pages of updates for your major release. You may want to just have a brief description of it and then say, read the changelog and keep the changelog there for the more robust notes.
Awesome. I have put every device I have on do not disturb, but apparently that doesn't work for all the programs. Some things override that. So sorry about the background noise. But thank you for that answer. Next question we had out in Discord is, a lot of organizations are moving calendar versioning for releases. Do you prefer one over the other?
It depends on the use case. So, for example, for all my presentation, like if anyone goes to that bit.ly link I posted in Discord to see the annotated version of my presentation, you'll see that it's prefixed by a calendar versioning number. So I think it depends on what you're doing. I would say for code, in my point of view, for code releases for going to production, I would rather stick with semantic versioning simply because it communicates the level of changes that are gone out. And then in there, usually what I do for my release notes, I started out with like released on, and then the date in that format of year, month, day. But it's based on what the organization want, what makes sense for you. But I think if you're putting anything out there that's going to be consumed by somebody or used by another group, I would recommend sticking to semantic versioning, just again, so you can quickly communicate the level of changes that you're putting out in your latest release.
I realized I had a typo in there. But for those of you who might not be on Discord but are watching this live or watching it in the future, because Bitly will work in the future and those slides will still be up, you can go to that address you see on the screen. And thank you very much for providing that out there. It's one of those things I developed a habit years ago with just thinking of everything in UTC timestamps. That now I think it's weird when I don't see things in UTC timestamp. Or ISO, not UTC, ISO timestamps, so it's year, month, day. But anyway, let's see. There's the next question, and you already answered this out on Slack, and this is one of those, or not Slack, on Discord. And this is one of those questions that probably is better written down as the answer, but we'll still give you a chance here, and I'll copy your answer over there as well. As you're answering this, but what's the actual syntax in the Git log? Pretty doesn't seem to work for our friend DJ Otaku out there.
Yeah, I mean the format, to best of my knowledge, and if I'm a command line junkie, so for Git, if you do git log and -- help, it'll give you all the details on the different ways you can format it. But what works for me is if you can do two commit numbers, usually separated by 3 dots. So like, the hash and then 3 dots in the next hash, or you can do the tag name, either annotated or the lightweight tag name. So tag, then ... and then you could do another tag. Like you compare two versions. If you do head, that's just going to do your current, whatever the head of your repo is. I think the important thing there is that pretty is separate. Pretty is about how you want the log to render or output, and then the tag. So you can leave out that pretty format and you can just compare two tags and it'll give you a whole log of all the commit messages in between. So doing the pretty format just gives you some ways to control what outputs. If you do like %s or modulus s in the format, that'll just be like the commit message. So yeah, they're my little example there. Get log pretty format modulus s, then version 2.8.0 -s or ... head, which before I typed that in Discord, I brought up my command line. And I typed that out to make sure I wasn't going to lie what I was saying. So definitely go to Git log or go to the Git documentation and it should help you out.
Man-Git is your friend.
Or you get Kraken and there's ways you can compare.
Actually, that leads us into a next question. And for this one, I'm not going to put you on the spot, Mike. I'm going to tag in, if you're ready to come in there, Jonathan, tag in our local product manager and host for GitKon and ask you this question. And Kraken Annotated gives a little line to fill in. Is there any way to get more space annotated tags similar to a regular commit? Thanks to DJ Otaku again out on Discord.
So you can definitely put in long text for a tag. This is a common feature request though. Right now, the only way that you can look at said long tag is to just use the tooltip from the left panel of Git Kraken. So if you do have one of those long tags and you just want to see the whole thing, your best bet right now is just head over to the left panel underneath tags and just use the tooltip to get the whole name. And thanks so much for the feedback. I mean, the product team is watching this feed right now, so this will be something that we can take back to discuss and see what we can do from there too.
Thanks very much, Jonathan. I'm going to excuse you for the rest of this Q&A. Thank you very much for indulging us there, Mike.
I know, I'm glad I would not have been able to answer that. So
here in the last few minutes we got left, I know it's not really covered and not really part of the topic here, but I'm really curious. MIT Sloan, a name probably everyone watching this ever will at least be able to see. Oh, there it is, MIT, where arguably part of the internet was definitely invented, and definitely where Git comes out of, or not Git, GNU and so much of the open source movement comes out of that gave us Git eventually. But I'm curious, this infrastructure that you all use, like you're using semantic tagging on something. And then I wonder if you could talk about a little step back a little bit and talk a little bit about those systems themselves, like what your setup looks like.
Yeah, I mean, I can. So my purview is like I said in my talk, I help lead and manage the MIT Sloan website. So mitsloan.mit.edu. So I can talk about that stack. I mean, MIT has so many different things that work so many
True.
different ways. So yeah, but with our structure, we use GitHub for our code repo to manage that, and we use pull requests for doing that. And for our automated deployments, we use Circle CI connected to that to then feed into our hosting provider. So we use an artifact-based repo. So one of the cool things we can do, and we haven't used GitHub Actions yet, but I've been working on ways to do it based on the previous talks. Like if we create a pull request, that triggers based on our Circle CI script. It knows it's not a release based on the tag name or that there's no tag name. So that generates a dev environment for our QA team to test it. But when we do releases, we generate a tag either through the GitHub interface or through command line or Git Kraken. And when we push that up to our GitHub repo, that triggers Circle CI. It sees that it, like the examples I showed in my presentation, that it matches version v.x.y.z. And if it matches that, it triggers a whole bunch of build steps in our Circle CI environment to build our artifact and push that up to our production environment and then sync that down to our lower level environments. So it takes a lot of the manual effort off of the team to have to do that. It makes our deployments, we deploy almost daily, and the deployment takes, like a half hour at most, because we sync to some other environments and we run some automated testing and visual regression testing and whatnot. So it's a lot of robots doing it for us, and I'm hoping to work on more robots to do more of the work for us. So I use something like that script that I linked to in that repo to help generate the tags. So again, I don't have to figure out what the last one was if I'm just updating a patch.
Right on, man. So we got one last question here, and I have a little bit of problems formatting thing. These comments only have so many characters they give you per line. So I'm going to reformat this real quick. All right. And then there's a follow-up question. For repos that have never had any standard versioning, and also a few users, is it reasonable to go back in time and add versioning as appropriate? So sorry, that's busted into weird 2 lines, 120 character limit. That's by Ugium out on their Discord.
Ooh, I guess it depends. If you've had a repo for a long time, it's worth a discussion with your team if it's worth the effort to go through, because you can always go back and you can generate tags for any commit. So you could go back and tag previous commits with version numbers and work your way up. But it's probably just reasonable just to start with where you are. The recommendation is, if you're working on something in beta, like you'd be 0.1.0 until you go to your first production release. So you could just start with version 1.0.0 and move from there, and consider everything else prior to that something, tech debt to handle to tag the releases previously. But I guess it's talking to your team and how much time you have and how far back in your history you want to go, or you just make a line in the sand and say, from now on, we're doing semantic releases, and you could just pick it from there.
Line in the sand moments, man. Sometimes you just have to say, from here on out.
Yep. That also removes it that you're right. It may seem like a big task, like, oh, we want to do this, but we'd have to go back to all our history and we don't have time for that. So then don't go back and do that. Just start from where you are and move forward.